Alright, now in this video we are going to look at, in fact it's going to be interesting in this video. We are going to look at graphs and their transformation. Graph and their transformation. Now, the general equation of a trigonometric function are y is equal to a sine into bracket bx minus c plus d and that of this. We are saying that this is the general equation of the trigonometric function when it is transformed. Or don't forget that what we have previously done for sine s, cos s, and all the trigonometric functions in the algebra, they were all at origin. But what if it is transformed? That is graph of their transformation. So we are going to look at all, not only sine and cos, but for all, we are going to look at 8 transformations. Now, the A here is telling us something, and that is telling us for the amplitude. That is the amplitude. So the absolute sign is equal. So for that one, we take the absolute of it. That means that the amplitude can never be positive. The amplitude can never be negative, but rather positive. So even if your amplitude is -3, take the absolute of it, and you get amplitude to be positive. Very good. The B and the C is equal to the phase shift. And the phase shift, if Bs minus C, if you have Bs minus C like what we have here, it will shift to the right. It will shift to the right. That is the phase shift. And if it is positive, it will shift to the left. It will shift to the left. So the phase shift, it depends on the value of the C. Okay, whether it's going to be shifted to the left or to the right. Is that clear? Very good. And let's look at the D here. Now let me make it plus or minus to make it general. Plus or minus to make it general. Very good. Now D here is a vertical shift. We are saying that this is the phase shift. This one is horizontal. Whether, so let me put here. So this phase shift is horizontal. So it's a horizontal phase shift. It's a horizontal phase shift. Very good. So these are horizontal phase shifts. Now, let's look at the D. The D is a vertical phase shift. And it depends whether we have minus D or plus D. This one will shift. This one will shift downward. This one will shift downward, and this one will shift. Make sure you take your note well. This one will shift upward. So we have upward phase shift, upward vertical shift and downward vertical shift. And for the phase shift, that one is horizontally. Okay, that one is horizontal. And whether shifting to the left or shifting to the right. I hope that is clear there. Very good. Now let's look at graph of a function in a certain form. Alright, let's look at graphing a function in the form a sine s or a cos x. But let's first of all look at a sine s. That's how we're looking at it here. Now, the a here, which is the coefficient, the a, that is when you take the absolute of the a, that is the amplitude of the function. And we have established that that is the amplitude of the function. So it is the same as the one at where it is transformed. The same thing. So that is that. Now, let's investigate on this amplitude. When the amplitude is greater than 0, the graph of the function stretches. The graph of the function stretches. That is when a is greater than 1. So when a is greater than 1, then it stretches. That means that, okay, I will say that later. So when a is greater than 0, the graph stretches. So when a is 2, the graph stretches to 2. When a is 3, the graph stretches to 3. When a is even million, the graph will stretch to millions. So the graph stretches. Please take note of it very well. 2. When a is less than 1 or greater than 0, when a is less than 1 or greater than 0, the graph of the function compresses. That means that the graph of the function will compress between 0 and 1. The graph, and don't forget that it is less than, so it is, here is, when the amplitude is less than 1. That means that here it can be half, it can be any value that is less than 1. And when it is greater than 0. So this means that it will be within 0 and 1, but it cannot go beyond 0 and 1. So what this means is that the graph of the function compresses or shrinks or shrink. Now, if the amplitude is negative, the graph of the function reflects about the x-axis. When it is negative, that means that it is reflecting about the x-axis. And don't forget, here we are saying that the amplitude can never be equal to what? 0. But, sorry, can never be a negative value, but it will affect the graph. Okay, when we are looking at this example, you get to see that your graph can have a negative in it, but doesn't mean that when you are taking the amplitude, you will include negative. Very good. So now, what this is just telling us is that, the value of the A determines the amplitude. The value or the amplitude is the largest value of the function will attain. The amplitude, so take note, and the amplitude is the largest value of the function attained. The largest value of the function attained. So let's come to this and look at graph. So let's look at this example. Graph the following: 2 sine x, 3 sine x, negative 2 sine x, half sine x. Let's look at the table and talk something about it. Alright, so I'll be back to the table. You can continue with your own by using the interval of 90 degrees and see what you're going to get. Okay, so make your calculators ready and let's see what you're going to do. So first of all, we can see that for all the four questions is involving with what? Sine. Don't forget we are looking for graphing in the form a sine x. Please, it's the same as that for cos. So you can even change all the sign and make it cos. Okay, I'll give you that as an assignment for you to do that. So let's do that for sine. So let's first do sine x before we come to this. Today it's 1, 2, 3, 4. So for sine x, what is sine 0? Sine 0 is 0. Sine pi on 2 will give you 1. Sine pi will give you 0. Make sure you use your calculator. And sine 3 pi on 2, that will give you negative 1. And sine 2 pi, that will give you 0. Very good. So since we have that the output for the sine, then when you multiply half by 0, you get 0. Half by 1, you get half. Half by 0, you get 0. How you can see that? Very good. Then half by negative 1, you get negative half. Half by 0, you get 0. Look at something beautiful that we are going to get. 2 times 0, you gain 0. 2 times 1, you get 2. 2 times 0, you get 0. You can put your calculator 2 sine pi on 2, you get 2. Okay? It's the same thing. What about 2 times -1, you get -2. Okay? Then here will be 0. Then we go for this, and that's going to be 0, 3, 0, -3, 0, 0, 70, 2, 0, -2, 0. Alright, don't forget that we said the amplitude is the largest value of the function attained. So looking at this function sine s, what is the amplitude? 1, very good, that is 1. Because there is -1, because you take absolute of it. So the coefficient is just the absolute. Alright. The absolute of the coefficient is the amplitude. So what the largest value attained here? Half. So half will be the amplitude. What the largest value attained here? That is 2. So 2 will be the amplitude. Don't forget, we take the absolute value of the coefficient. So 3 will be the amplitude. But here, we take the absolute of this, which is 2. So 2 will be the amplitude for 3, -2 sine x. Very good. So, hope you can see how it is. It's very nice. It's very nice. So, that is that. That is that. Now, you can see that for 0, for pi, and for 2 pi, we are getting that place with 0, 0, 0. And hope you know that once this result is 0, no matter the coefficient will be, or the what the amplitude will be, you will be getting 0, 0, 0, 0. Alright. Oh, I nearly forgot. Please, for your assignment, change the sign to cos, and get me the value for that. Change it to cos. So here, write cos, half cos, 2 cos, and get me a new table and investigate and see if the idea of the amplitude will be working or not. Alright, I hope you are done with the table for that. And don't leave it as such. I have taught you how to graph it. So make sure you go and graph and appreciate the beauty of how that is going to give you. Yeah, go and graph that for the sine example and that for the cos example that you just did. Very good. So let's look at graphing a sine bs or a cos bs. So here the focus is now that what if we have the coefficient of s here in the argument to be a value? It can be 1, it can be 2, and if it's 1, then it's the normal one. But it can be 2, can be 3, it can be 4, it can be 5. In fact, let's investigate on that and see. The graph of the functions have amplitude day. So the graph of this function have this amplitude. So the amplitude is the same thing. And period 2 pi over 3. And period 2 pi over 3. In fact, I would like to leave it in general to say that that's going to be 2 pi over b. 2 pi over b. Okay, 2 pi over b. The appropriate interval of one complete period. The appropriate interval for one complete period is 0, 2 pi over b. That is for one complete period. Now, let's conclude. Now, if b is less than 1 or greater than 0, the period is greater than 2 pi. The period will be greater than 2 pi. And represent a horizontal stretch, and that represents a horizontal stretch. So we are saying that even though we know that the period for sine is 2 pi, the period for cos is 2 pi, but that is at origin. Here, bear in mind that the amplitude is not the focus here because the amplitude will not affect the period. There is no way the amplitude will affect the period. No matter what amplitude we have, it will never affect the period. But what the B is going to be can affect the period. Alright? So we are saying that if B is less than 1 or greater than 0, the period is greater than 2 pi and represents a horizontal stretch. And 2, if B is greater than 1, the period is less than 2 pi. How do you see that? The period will be less than 2 pi and represents a horizontal shrink. Don't forget it. Horizontal stretch, horizontal shrink. Very good. It can be given to you as a fill-in or objectives. Alright, 3. If B is negative, use and to rewrite the function. Very good. So by at times, most of the times it's given to you in it's given to you as positive, but not all the time will do. So let's see what that is going to be. All right. So let's look at this example. Make sure you write it. Hope you are done. Okay. Let's look at this example. Okay. We have to graph the curve of 2 cos 3x. 2 cos 3x. So here, simply, you can see that the amplitude is going to be the average of A, which is 2. So the amplitude is 2. But the period is going to be 2 pi over B. But the B here is 3. That's the coefficient of the argument S. So that's going to be 2 pi over 3. So this is the period. Very good. And if you want to write it in the point form, that's going to be 0, 2 pi over 3. Very good. So you move on to do the graph, okay? So do the graph yourself, So this is going to be the interval. Yeah, this is going to be the interval of the period, the interval. So the interval will be 0, 2 pi over 3. And also, please after here, you can go and graph it, okay? You know what to do your. Alright, let me show you the technique in coming out with the table for the graph. Because once you get the table correctly, getting the graph is just easy for you, okay? Once your table is correct, graphing is not a problem for you. Because you have been doing graph since day one. Very good. How do we do the graph? We have the technique. And the technique is just simple. We are going to count, all right? Now, we want to get only 4 divisions, all right? Only 4 divisions on excluding the origin. We know that they'll start from 0, but I want to exclude the origin. We want to indicate only 4 points, all right? But here I'm basing on the positive side. Don't forget, I'm basing on the positive side. So we always start from 0. So the 0 is not part. Leave that part. Leave it. Very good. So yeah, we always start from 0. That's why the interval here is 0, 2 pi over 3. That is for the period. Right? I'll come to that part. I'll come to that part. But let's look at something here. So the count. Here's how we do it. All right. We are saying that a period, that is how far you want to be. All right. So if I have a period of 2 pi over 3, and I want to divide 2 pi over 3 in 4 divisions, what do you think we have to do? Then we have to multiply it by 1 over 4. Or in the same way, dividing it by 4. So we have to multiply it by 4 to get the 4 divisions. To get the 4 divisions. Don't forget, I said we start with 0. So you multiply 1 over 4 by the period, which is 2 pi over 3. And this is going to give you, this goes here 1, this goes here 2. So 2, 3, 6. So we get 1 over 6 pi. So after getting the division, then we start counting. Don't forget, we start from 0. Then you add this to 0, and you get 1 over 6 pi. I hope you are watching. Now, add 1 over 6 pi again to, okay, in order for us to clear confusion, okay, we can use that, we can use that. Very good. Now, let me help you a bit. With this, you can get rid of the pi. Okay, you can get rid of the pi. But the count starts from 0, then you add 1 over 6. But here, you have to include pi to it. I don't know whether this may be confused. Don't worry. Very good. But let me lay emphasis on this. So you start with 0, then 1 over 6 pi. Because you add 1 over 6 pi to 0, you get 1 over 6 pi. Very good. Now, then you add 1 over 6 here to this result. Okay? Here, I don't want you to say that I'm adding 1 over 6 pi to 1 over 6 pi. That will be somehow confusing for you. So, add 1 over 6 to 1 over 6 pi. Rather. So that you will not be confused. So 1 over 6 plus 1 over 6, and you are going to get 1 over 3. So here 1 over 3, then you bring the pi. I hope it's clear. You're getting what I mean. Then we are adding till we get to the period, then we end. So 1 over 6 plus 1 over 3, that's going to give you half. Half, then you bring the pi. I hope you can see that. Very good. Now, the 1 over 6 again, adding to half. 1 over 6 again, adding to half. You get 2 over 3, and you bring your pi. And you can see that that is the period. That is the period. So, we end it. Here, you end. You don't continue. When you get to the period, then you end. How you can see the technique? Very good. So if you start with 0, the next will be 1/6 pi. The next will be 1/3 pi. The next will be half pi. The next will be 2 over 3 pi. Then you end it. Is that clear? Thank you for that. I hope it's clear. I'm sure. So now take your calculators and let's move on. Should I repeat again? All that I'm saying is that when you get your period and you want to go and draw your table, you need the 4 divisions. Don't forget we are starting from the origin, which is 0. Alright. So we want to divide this period 2 pi over 3 into 4 divisions. That means that you multiply the period by 1 over 4, or you divide by 1 over 4 in order for you to get the division. So this means is that we start with 0, then we add 1 over 6, 1 over 6, 1 over 6, till we get to the end. So you get rid of the pi, you get rid of the pi. So you start 1/6 plus 3, that would be 1/6, then you bring the pi. Get rid of the pi. 1/6 plus 1/6, you get 1/3, then you bring the pi. 1/6 plus the results here, not here, but the results here, then you get like that. So you get to the period. Now take your calculator, wherever you see S, put 0 here. For you to get the value here, put 0 here. And that is going to give you 2. Very good. So our first point. So this means that our first point. So this means that our first point is 0, 2. Then we move on. 2 cos 3 times 1/6 pi. That is going to give you 0. 0. Then for this you get -2. Then for that you get 0. Then for that you get 2. You can do it your own, so make sure you do it. Very good. So what is interval? You can now get the idea of the interval. What is interval here is telling you that it starts from 0, then it ends at 2 pi over 3. So for you to get the divisions in 4 thirds, you have to divide it by 4. You see, from 0 to 2 pi over 3. Very good. So the next point will be 1/6 pi 0. The next will be 1/3 pi -2. The next will be half pi 0. The next will be 2/3 pi 2. Alright, so how many points are we going to get? 1, 2, 3, 4, 5. So we have 5 points now. Very good. There you go for your graph. Let me assist you to graph this. Then the next, the subsequent one, you will do it your own. You do it on your own. So make sure you stop whatever you're doing to focus on the board. Oh, as I said, I'm focusing only on the positive side. Only on the positive side, so this is 0. Very good. Nice one. Alright, so now from 0, then we get to 1/6 pi, then we get to 1/3 pi, then we move to 1/2 pi, then we move to the period. That is where you are ending. Now we are graphing it at 1 period. 1 period means that when you get to the period, then you end. Okay. So what about the y? On the y-axis, the maximum value is 2. So 1, 2. -1, -2. At 0, we have 2. At this, we have 0, -2. 2 power 3, we have 2. Very good. So let's see, we start with this. Very nice. So the graph is not difficult. So this is 1 period. Why is it 1 period? It just 1 period. If you are going for 2 period, because that one you are going to, if you are going for 2 period, that means that you multiply this by 2 and divide by 8. So that one is going to give you another 1. I hope you can see that. Oh, I said you multiply by 2 for 2 periods. I'm sorry. For 2 periods, you don't multiply by 2. Please, I'm sorry. I'm sorry. I don't mean that. For 2 periods, you divide by 8 so that you can get another division. So that one will continue as that for 2 periods. You can choose not to even indicate that on the graph. Sorry, on the table. And you're going to get that to be like this. You can guess with that. And that one will end there. So this is 2 periods. So for 1 period, bam. For 2 period, bam. That's that. So this is going to be for 2 periods. So you are just to know the value that will be here. Okay. Alright. So that is what we do for 2 periods. That is what we do for 2 periods. You just continue it like that. And there will be one. So know the interval. So the interval from here to here is 1/6 pi. So for 2 periods, add 1/6 pi to this. Add 1/6 pi to this, and that will give you the 1 here. Add 1/6 pi to this, and that will give you the 1 here. Add 1/6 pi to this, and that will give you the 1 here. But this one will still be 2, and this will be -2. Alright, that is for 2 periods. So that one, for 1 period, you divide by 4. Then you start adding, multiply. But if you are going for 2 periods, you keep adding till you get to this. Or after graphing it, then you continue to add the 1/6 to get these values, and that is all for 2 periods. Very good. Let's move to second question. So let's graph this in 2 periods. So the first thing to do is to go for the amplitude. And you know that the amplitude is the average of the A. And the coefficient here is 1. So average of 1 is 1. So the amplitude is 1. Then the next thing to go for is the period. Don't forget the period. Now the period, we have 2 ways to solve the period. The first one is you knowing that it is 2 pi over b. Alright. Where here the b is coefficient of the s, which is half. So this is going to be 2 pi over half, and that is going to be 4 pi. 4 pi. Very good. So here the period is just 4 pi. Method 2. Second method is that we know the rate for cos. For cos and sine, it's the same thing, 2 pi. So 0 less than equal to 2 pi. Alright? And what will come here is the argument. And what is the argument? The argument is half s. The argument is half s. So what will be in the middle will be the argument, which is half s. So we are going to manipulate this in such a way that we get s at the middle. We get only s at the middle. So what will you do to undo this half? That is multiplying both sides by 2. So 2 times 0 less than or equal to 2 times half s less than or equal to, because in equation or inequality, what you do to this side, you do the same thing for the other side. So 2 times 2 pi. This will give us 0. This will give us s. This will give us 4 pi. Very good. So you can see that here the period, therefore, the period is 4 pi. By the interval, oh, you see, with this method, you can see the interval straightforward. The interval the interval is 0 for pi. How is clear? Method 1, method 2. Which one do you like? Me, I would advise you always go for this. Because I don't want you to choose that formula. That the period is 2 pi over b. No, I don't want you to go by that. Go by this idea, and this idea will even help you when you get to the transformation, the one which is transformed. When we have bs minus c and all that. This method will help you. Just write 0 less than or equal to 2 pi. Leave the inside. Whatever the argument will be. If the argument is 6 pi, don't write 6 pi. If it is 1,500 pi, don't write 1,500 pi. And do whatever you do to undo that. And that is all for that. Very good. So that is how we do for that. What's the next thing? You have to go for the table. So to go for the table, let's go for the count. Let's go for the count. So what is the period? 4 pi. So we multiply. We are taking this into period. 2 period. So don't worry, we'll do that. We multiply 1 over 4 by the period. By the period. And 1 over 4 times 4 pi is going to give you pi. Alright. So I'll say 1 pi. It's going to give you 1 pi. I don't know if I want to write it that way. You may not understand, but let me do it that way. Now, the interval is saying that you start from 0, then you start adding 1. Okay? So 1 plus 0. So you start from 0. So now 1 plus 0, that is 1 plus 0, that is 1. So here will be pi. Then you add again 1 plus 1, which is 2. Then you bring your pi. Now you can see why the reason why I'm bringing the 1. Very good. So here 1 plus 2, you get 3. Then you bring the pi. You are doing till you get to the period 4 pi, then you stop. 1 plus 3, you get 4 pi, then you stop because that is the period. So what is going to be the point? Let's go for the table. I hope I can clean it. So for the table, we start from 0, pi, 2 pi, 3 pi, and 4 pi. Now, take your calculators and let's move on. Y is equal to cos half s. So cos half s. So cos half 0 will give you, I'm sure that's going to be 1. Then for pi you get 0. Then, alright, here you get negative 1. Then here you get 0. Then you get 1. Very good. Then you go and do your graph. Alright. But don't forget that we are doing for 2 periods. When you end at 4 pi, that is 1 period. So I don't want you to include all on the table because if you want to do that, that means that you have to go till you get to 8 pi. That will be 2 periods. But if you include that, your table is going to be 2 bunch of stuff. So let's do that on the table on the graph. Let's go and do that. It's as if you are sketching for 1 period, but we're going to do 2 periods. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, Oh, I don't want to bring that. Yeah, I think we are drawing for one period. So let's go. At 0, we have 1. At 0, we have 1. At 5, we have 0. Okay. So this goes like this. So please listen to me. This is one period. When you multiply by 1/4, you multiply 1/4 by the period. Then you start adding till you get to the period, then you stop. That is one period. So for you to get for 2 periods, watch. When you bring the negative side, it doesn't mean that it's 2 periods. So someone will say, oh, 1 period, 2 period. No, you want to see 2 periods on the positive side and on the negative side. By the negative side, you can ignore that. So let's focus on the positive side. So next will be this, you can get that, and that will be this. So definitely, there is going to be -1 like that. Here is going to be 1. Okay, so there should be the argument for this and the argument for this. Okay, very good. So let's guess. Let's guess. We are adding pi. So pi plus pi, you get 2 pi. Pi plus 2 pi, you get 3 pi. 3 pi plus pi, you get 4 pi. Let's move on. 4 pi plus pi, you get, so here will be 5 pi, here will be 6 pi, here will be 7 pi, here will be 8 pi. Hope you can see that. So for 2 periods, you add till you get to twice of. That is what I was wanting to say. You add till you get to twice of the period. Take note. Because when we have a period of 4 pi, we multiply by 2, get 8 pi. And that is where the 2 period is ended. So for 2 period, you multiply 8. Sorry, you multiply 2 by the 4 pi. So you add so you get to that value. And that is for 2 pi. Thank you for that. In fact, I would like to give the rest for you to go and submit on your own. Oh, is there any? No. But let me try to get you some. I will still try and get you some. Alright. So you can go and try on this. So this is for 2 pi. Please don't forget. But if it's 1 pi, you just end with this. I said 1 pi, so 1 period, you just end with this. But for 2 pi, then you continue. Alright, so let's go and try on this. Graph the following. In 1 period and 2 period. 1 period and 2 period. And so that is that. Go and try on that. In our next video, we are going to, please make sure you do it well. In our next video, we are going to look at the case whereby the argument is shifted, whether shifted to the left or to the right, and also whereby we have the vertical shift, whether shifting upward or downward. We'll be looking at that. In fact, you will have, trust me, and see you in that video. But please don't forget to subscribe to Mass Expect YouTube channel. Wherever you got this video from, please, I don't care. But go back to YouTube, search Master's page and subscribe to us. Thank you.